3 points T, U, and V on the number line have coordinates little t, little u, and little v, respectively. Is point T between points U and V? So without knowing anything more about these points, we got to look at our statements. Statement 1 says T squared is less than 4, which is less than U squared, which is less than V squared. So what are you doing when you square something? So one reason people might square something is when they only want to be taking into account the magnitude of a number or a variable. In other words, they want to disregard the sign of that number, whether it is positive or negative, and only take into account how far that number is from 0. And so that is also the reason why when you take the square root of x squared, for example, it is not equal to x, it is equal to the absolute value of x. So in this case, by saying t squared is less than u squared, which is less than v squared, we are saying the magnitude of t is less than the magnitude of u, which is less than the magnitude of v, which is all the same as saying t is closer to 0 than u is, and u is closer to 0 than v is. So if we were to take the square root of our entire inequality here, it wouldn't be t is less than 2, which is less than u, which is less than v. It would be the absolute value of t is less than 2, which is less than the absolute value of u, which is less than the absolute value of v. So with that in mind, so let's try and draw some examples of what our number line can look like. So let's start by drawing u and v first. So v has to be further from 0 than u, so maybe I'll say v is equal to, if I sort of want to test wide ranges or extreme examples, let's say v is equal to 100, u is equal to -10. So that works because those are both more than 2 away from 0. And then I can say t is equal to, so t is just got to be less than 2 from 0. So let's say t is equal to 1. And now we have an example where t is between u and v. So we have a yes to our question. So can I get a no to our question? Can I get a same example, but where t is on the outside of u and v? And it seems like if I just move u around, if I just make u positive 10, then this works. So t is still closer to 0 than both u and v, and u is still closer than v is. And so, but t now is on the outside, so we have a no. So that makes statement 1 insufficient. Statement 2 says u is less than 0, which is less than v. So this is just telling us u is negative and v has got to be positive. But also remember, we got to forget our information from our first statement. So by itself, this should be a quick insufficient, because this doesn't tell us anything about t, which we would also have to know something about to determine if t is in between u and v. And so this question is sort of going straight to looking at them together. So now, using our restriction from statement 1, but also knowing that u has to be negative and v must be positive, does that help us at all? So if I want to try and reuse the examples I came up with in my first statement here, it looks like I can reuse this one because u is negative and v is positive. I cannot reuse this one. So will this always be the case? And let's think about it. So what so if this is 0 on our number line, and we know U has to be over here somewhere, and we know V has to be over here somewhere, but we also know T has to be closer. So if T has to be closer to 0 than U, that means it's got to be to the right of U. But if it also has to be closer to 0 than V, well, it's also got to be to the left of V. So what is that really telling you? It's another way of just saying T must be between U and V. So together, we can answer yes to our question. So it is sufficient to say yes. C is our answer.